So I was researching this talk last week and exploring block explorers in the general ecosystem. And as one does, I ended up on Etherscan pretty quickly, on the mainnet anyway. And came to their privacy policy, which is actually fairly disturbing. I was ending up kind of clutching my treasure there, curled up in a ball. Some of the types of data that they collect, potentially, personal information like your name, your date of birth, other personal identification numbers, contact information, address, phone number, email, technical information like your IP address. And they use this data in ways that we're unsure of, sharing with data warehouses, marketing agencies, and other various organizations. Now, as a casual user of Etherscan, you're probably not going to run into this. If you're signing up for an API key, you probably will. If you want to add your own messages or content, they store that, and we're not sure what they do with that data. So that was part of the impetus behind building BlockScout. It is an open source explorer that also supports Ethereum Classic. I forgot to mention, that's another reason why you might not use Etherscan with Classic. It's not supported. So last year at the summit, our tech lead, Igor Baranov, gave a great demonstration on kind of an earlier version of BlockScout. And I'll talk a little bit about a few of the things that he spoke of. First of all, it's built on Elixir, the Erlang VM, which was originally built for telecommunications processes. So it's really good at concurrency. You've got, with BlockScout, we're fetching the first blocks in the chain, and we're also going backwards to get some of the archived data. So we need those kind of concurrent processes working. He talked about how there's support for different kinds of tokens, ERC20, ERC721, smart contract reading and verification. So when you're verifying a contract right through the UI, you're able to go through that process really easily. And basically that just verifies that the bytecode matches the contract. It's not verifying that the code is actually correct. Also, full transaction history. So in the past year, we've been fairly busy, and I want to speak with you about the ways in which we've been improving BlockScout. Basically, we've taken three approaches. We're working on some different tools and views for developers, performance optimizations, and we've actually really been focusing on the user experience. I've heard several people talk today about how important it is to kind of build that bridge between users and developers. So we're working on that to create a full-featured Explorer. So one thing we've been working on is creating a decoded view for the contract method calls. So basically just including this information in the Explorer itself. You can see here we have the method ID, the type of call, this is a transfer call with the arguments that it takes, and then the data that was presented. You can also copy any of that data as you need to. And this actually works for non-verified contracts as well. We're creating a library of these different method signatures so that you can go in and, in an unverified contract, you'll still be able to see what these method calls are. Similarly, we've added views for the logs. So in this instance, it might be a little hard to see there, but the first topic, again, is the message signature, and we're able to extrapolate those out so that you can see different types of data right in the interface. We've also added a search functionality to the logs, so you can parse through the logs rather easily. We've added this raw trace functionality, and we store this to the database, so the same type of JSON object you would expect to get from Geth or Parity, you can access here. And you can see on there's the internal transactions view, and then the raw trace view. So offering just different views, different ways of looking at the data and being able to use the data as you need. We've really been focusing on some API improvements as well in BlockScout. And there are no limits to how many times you can hit the APIs. There's no keys that are needed. You can make requests directly from the UI. And we offer GraphQL support. We're also starting to support some of the JSON RPC endpoints. We found that these were the three most common ones: the ETH block number, get balance, and get logs. In addition, we've extended the RPC endpoints for contracts. So the list contracts endpoint, you can go in and find verified contracts or unverified contracts easily with that call. There's also a verify endpoint. And this is useful for third-party services, for example, Truffle, or we're talking with Etherlime right now so that you can actually write a contract there, compile it, deploy it, and verify it right through that interface. So as far as optimization goes, we're using something from Elixir called ETS, Erlang Term Storage, to really try and make the page load quicker. So you can see here average block time, the total transactions, total blocks, and wallet addresses. Those are all being served from ETS, as are the top 5 blocks in the chain and the top 5 transactions. So that way we can get things to the page really quickly, and we don't have to call the database every time. Once we get past those 5, we just prune it and continue with that process. On the front-end side, we've been caching as well with local storage. So if you go back here and see that the chart, that's actually cached in the local storage. And we've been working on isolating a lot of our code. So before we had just this really, really long CSS file. And as we've been adding more chains, it really got out of hand. So now we just have files that are just related to the page you're on. We've also added pagination so that only the top 50 results come up and you can go through. And these might seem like little things, but when you add them all up together, it's really improved performance, which is such a big thing for block explorers. If you're waiting around for the data, it's not good. Along those same lines, we've really focused on the user experience. It's related to this idea of competence. When you see a good design, you automatically feel assured that it's a working product. That builds trust, and that builds adoption. And that's really what we're looking to accomplish here. One of the ways we do this is through eliminating some of these kind of black hole pages. So before, if someone would come on and look for a transaction and it wasn't there, they ended up on this scary white page and didn't know what had happened to their transaction. This is for a lot of users, naive users perhaps, who don't know that you need to wait a little while. So we've added this messaging just to assure people, okay, come back in 30 seconds, refresh. In all likelihood, your information is going to be there. We also have clear labeling of the different types of transactions. This was part of our 2.0 redesign. So contract calls, transactions, token transfers, all those types of things are clearly labeled in the UI. We've added a CSV download. This is especially good for users who want to download different transactions from their account or see all the transactions that happened with a smart contract. And these are the different headings for that CSV download. And night mode, which I've gotten emails recently from Slack and Google Docs and many other big corporations that are adding night mode, so we're happy to be ahead of them. But it really is something that helps people who have vision problems, that helps people who are on their computers all the time, and it shows that you're committed to that UI experience. So we're really trying to make BlockScout a beautiful and fun experience for users. Some of the things we're looking at in the future, the ability to write contracts right into the interface. So you can read and verify right now. We'd like to have the ability to actually write them. We're adding additional metadata for non-fungible tokens. So things like CryptoKitties will have the image there. Any other kind of non-fungible tokens, different metadata would then appear in the search as well. We have a community member who's working on showing daily transactions. That's actually an open PR. And to go off of that, we do have a community-driven roadmap. BlockScout's one of the most active projects in the Ethereum ecosystem. It's consistently in the top 20 as far as GitHub commits. So we're always looking for people to contribute, to add issues, to work on issues. And that really helps to drive the project forward. Briefly, I want to talk about a few of our other POA products that support Ethereum Classic in particular. This is Nifty Wallet. It may look somewhat familiar. It is basically a fork of MetaMask with some nice reskinning and the additional RPCs of Ethereum Classic, various test networks, Gurley, and some of our other chains. So we wanted to have a wallet that natively supported other EVM chains. And MetaMask was not so open to the idea. So in the spirit of open source, we made that idea our own. And hope that others continue to do that with this product as well. Another cool thing you can do with Nifty Wallet is make contract calls directly from that interface. So it's really good for testing different calls to make sure they work on a test net. Our TokenBridge is another technology that we're really proud of and that we're really working hard on right now. This is a live bridge right now from Ethereum Classic to the Ethereum mainnet. The way that it works is basically ETC is put into a smart contract. It is locked there. It goes through an oracle. And there's a smart contract on the mainnet that then mints something called WETC, which is wrapped ETC. It has all the same properties of ETC, but it's on the mainnet. And from there, you can use it on the mainnet freely as you would any other ERC20 token. There are at least one exchange that I know of, IDEX, that supports it. I believe Saturn also supports it on the mainnet. When you're done, you can bridge it back over to Classic. So it's a similar process in reverse where the WETC is burned, and then it's unlocked on the ETC side. This is a new bridge mode that we're working on. It's called the AMB bridge, arbitrary message bridging. And this is going to allow us to bridge any asset from two EVM chains. So ERC 721s, 677s, basically any kind of message invocation will have the opportunity to be bridged from one EVM chain to another. We currently have a working model on the Sokol and Kovan testnet. And we really encourage you to check out how that works. And we're hoping to have an ETC implementation at some point. If there's anyone here who's interested in helping with that, we're definitely open. So a little bit about the POA network. We are an EVM sidechain, and we heavily believe in interoperability. So the desire to have different chains that have different characteristics, potentially, for example, POA Network is heavily focused on games. We have the XDAI chain, which is a stable chain, and other networks that potentially can bridge to one another and have the opportunity to share assets, as well as sharing assets with the mainnet. So this is our contact information here related to BlockScout, as well as the POA website. We're active on Gitter and many other channels. And that's all I have today. Thank you. Any questions? Thanks.
Thank you.
Thanks. Appreciate it.
There you are.
All right.
The goods.
Thank you.
Right.